this lecture, I'm going to cover how we assess the impacts of climate and climate change on human life, and from 2 points of view. One is, how can those impacts be quantified and measured and documented? And then go a little bit more in some of the details about what are some of the key climate-sensitive sectors and what are some of the impacts that we can observe and also would expect to continue to see in those climate-sensitive sectors. So with respect to how impacts are assessed, there is a policy vehicle within the United Nations Framework on Climate Change called the Warsaw International Mechanism for Loss and Damage. And that mechanism seeks to minimize and avert loss and damage associated with climate change. And they divide the loss and damage into loss and damage associated with what they call the slow onset phenomena, things like desertification and acidification and sea level rise, and the more rapid onset event types of losses. There are methodologies that have been used in hundreds and hundreds of cases to assess what the impacts have been of any kind of climate phenomena or event. This methodology was invented, in fact, by the United Nations, the Economic Commission on Latin America and the Caribbean, to measure losses associated with floods and droughts and other kinds of extreme events that were occurring in the Latin America Caribbean region. And that method, which fills 4 volumes, is now being expanded to be used all around the world. So the way it works is we have a set of social sectors, productive sectors, and infrastructure sectors. And within each one of those, we have a set of subsectors: housing, education, and health. Social infrastructure is things like roads, bridges, water and sanitation, energy systems, and then the productive sectors would be things like agriculture, industry, trade, and so on. So when an event strikes, there are collections of assets that produce the value within those sectors. And those assets, because of their exposure and their vulnerability characteristics, to one degree or another, can be damaged or even destroyed or lost. So the ECLAC methodology is basically an accounting system. It says, okay, let's count how many of these assets, how many schools lost their roofs, how many books, how many chairs, how many days were the teachers not there, how many days could we not have classes, and so on. And then you convert those damages and losses into their economic equivalencies. What was the cost of those assets, and what is the loss to the economy going forward until those assets are repaired or replaced? You put all of that in a giant macroeconomic model, you mumble some hocus pocus, and out comes the macroeconomic loss to GDP from all of that. So there are many examples that you can find online of how this is done. So we can apply those same metrics to any event which occurs, even if it has a large signal of climate change in it. So when we look at how those sectors have been affected and how they are being affected, we can get a sense of what some of those impacts really are. Climate-sensitive sectors include things like food and agriculture, for example. Whole crop regions now, which are breadbaskets of the global food economy, could begin to move. The climate conditions that allow one crop to be grown currently may move somewhere else, and we either have to change the crops or we have to move the crops to those new places. Extreme temperatures and precipitation can have big impacts on crops, and that can affect global food supply, and we've seen some cases of that in recent years. Health is another one. You have waterborne diseases, you have vector-borne diseases, you have even airborne diseases related with dust and things like that. And when those conditions are prevalent, people become, to a certain extent, immune to those, or there may be low levels of endemic incidence of those diseases. But when those conditions migrate to somewhere else where people are not usually exposed to those things, you can have epidemic conditions, malaria outbreaks or dengue fever outbreaks, Zika outbreaks that have some kind of climate component that can cause a big spike in morbidity and mortality. The energy sector is a very interesting one for 2 reasons. One, extreme events, of course, have impacts on energy systems, power lines, hydropower, and all of those things. But also, in order to mitigate climate change, there must be a wholesale transition from fossil fuels to renewable energy sources. And when we look at those renewable energy sources, solar, wind, hydro, they are all extremely climate sensitive. So those systems themselves will be affected by climate variability as well as climate change over the lifetime of some of those installations and assets. And finally, when it comes to people, of course, inundation of low-lying areas. Where are all those people going to go? They can't stay there and get flooded time after time. There are lots of people, billions of people even, living in areas that will become uninhabitable. They will have to move somewhere else. And I should not fail to mention that there are gender dimensions to these impacts as well. Men and women are not all affected in the same ways, and so and neither are different kinds of communities and economies. So the impacts of these extremes and these slow onset events will play out very differently in different cases depending on things like gender, age, and economic well-being.